Hello everyone. This is part 2 of homework number 4. We left off with the concept of solving linear equations when the variable is on both sides. And recall the idea was to bring the variable to the side where the coefficient is greater. So we extend the idea and we look at the fact that we may need to combine like terms before transposing. And when we say that, I should stress this is on either side of the equation. So the equation is a barrier and you can't cross it unless you transpose. So if we're going to combine like terms, we have to look on either side separately. And in example 8, we could see that the variable's on both sides, but on the left-hand side, excuse me, we have these like terms, 8x and 3x. Excuse me, 5x and 3x. And therefore, before we start the transposition, you want to combine those. And so combining 5x and 3x, we get 8x, and that's equal to 7x minus 9. You just recopy the right-hand side. Notice that there are no like terms on the right side. Okay, so then we have the variable on both sides. And remember, the idea was we want to bring the variable to the side where the coefficient is greater, and that would be the 8. So we're going to bring it, the 7x to the left by transposing, adding the opposite, or subtracting 7x. So if we subtract 7x from the right, we're going to subtract 7x from the left as well. Line up our equals, there's our addition bar. 8x minus 7x is 1x, no need to break the 1. Line up the equals, bring it down. 7x's are gone, no need to write 0 in there. Just bring down this negative 9 and tuck it in, and that's our solution. Okay, in the second example, again we have like terms. Notice on the right hand side, there are no like terms. We're just going to end up recopying that. But on the left, we see like terms. 2x and the 3x. And they're both positive, so combining we get 5. And carry along the variable x. Then we'll combine the constant terms as well. The negative 7 and the negative 2. Combined to give us a negative 9. And then we recopy the equals, and the right hand side 4x plus 3. Okay, again the variable's on both sides, and the coefficient is greater on the left, so therefore we're going to transpose the 4x to the left hand side by adding the opposite or subtracting 4x. You always want to move the variable first. And let me mention this as well. Before you start the transposition, the worst case scenario should be something like ax plus b equaling cx plus d. That is, variable and a constant equal to a variable and a constant. If you have more than that, more than two things on either side of the equation, then you know for sure that you can combine like terms, like we saw in this situation. And then you can see this is what I'm talking about. There's variable and constant equals variable and a constant. That's the general form. And when it is of that form, it's generally, well, when we get to the multiplication property, we're going to say it's generally a 3-step process. But in this section, it's a 2-step process. In this case, we're subtracting 4x 5x minus 4x is 1x, or just simply x. We bring down the negative 9, line up the equals. The 4x's vanish, and it's equal to 3. And we want to bring the 3 down right next to the equals. So now that we've isolated the x, we have the x on the one side, we get the numbers on the other side. So we're going to add the opposite, zero out this negative 9 by adding 9. You want to show it literally, add 9 to both sides, line up the equals, there's the addition bar, the 9s go away, we'll bring down the x. Again, no need to write plus 0, just tuck that x in right next to the equal sign, do the arithmetic. 3 plus 9 is 12. Alright, so now extending the concepts even further, we have what is called the distributive property of multiplication over addition. And I didn't state it, I wanted us to write it out, and we're going to write it in general. It's A being multiplied by a sum, and we'll call it B plus C. And formally we just call it the distributive property, but typically we just call it the distributive property, but formally it's the distributive property of multiplication over addition. See, we understand the A is being multiplied by this quantity that's in parentheses. I mean, if you wanted to put a multiplication dot in there, you could, but it's not necessary because it's understood that if something is out in front of a set of parentheses, that it's implied multiplication. So there's the multiplication over this addition. And most people will use these little arrows to indicate the distribution. So A is distributed to the B, so that becomes A times B, or just AB. And then over the addition, A is distributed to the C, and that becomes A times C, or just AC. So that's our distributive property. And if we're solving any equation, that's how we remove the parentheses, by the distributive property first. That's the first thing you do. You see a set of parentheses, you have to get rid of them, and that's by the distributive property. So in this case, I think I'm going to recopy it. And we see two sets of parentheses. So remove them. The 5 gets distributed times the 3. That's 15. And then over the addition, or subtraction, could be as well, 5 gets multiplied by n. And you multiply the coefficients. It's understood there's this 1 here. It's not imaginary. I remember a student saying it's an imaginary 1. It's just understood that it's a 1. It's not an imaginary 1. So you multiply 5 times 1, you get 5. You carry along the n. It's positive, so plus 5n. And that equals... Now the closure of the parentheses here stops the distribution. So now you distribute the 4. Times 2 gives us 8. Plus 4 times n. Again, there's a 1 in there, if you like. And that's 4n. Alright, so now variables on both sides. Let's get it to one side if 5 is bigger than 4, so looks like we'll move them to the left again by subtracting 4n. Made a mistake there. So we're subtracting 4n from both sides of the equation. There's our addition bar. We'll need to bring down this 15. 5n minus 4n is 1n. We have to write plus to separate the terms. We could just write n. You could write 1n if you wish, but let's just write 15 plus n, line up the equals, bring down the 8, and the 4 n's are gone. So now we have the n, the unknown. On the left, we want to bring the numbers to the right. So we have to get rid of the 15, undo it, transpose, add the opposite, or subtract 15. Line up the equals, subtract 15 from the right as well. Here's the fraction bar, the 15s are gone. Bring down the n, line up the equals, combine 8 with negative 15, and we get negative 7. Okay, so here's another example where, again, I'm going to recopy it. You don't have to recopy it, but actually when you do your work in my math lab, you're going to be reading it off the screen, so you're going to have to copy down the original. And we see a set of parentheses, so we distribute. So the negative 3 gets multiplied by 2x to give negative, oops, I'm going to do it here, I'm sorry, in my recopied form. So you just multiply negative 3 times 2 and get negative 6, carry along the x, then distributed. Negative 3 times positive 5 is negative 15, and that equals, we'll just recopy, minus 5x plus 4. Okay, now here's a case that you may think is a little trickier. When you compare, we see the variable is on both sides, and when you compare their coefficients, negative 6 and negative 5, negative 5 is actually greater than negative 6. If you look at the number line, let's say that's 0, here's negative 5, negative 6 is more to the left. So negative 6 is less than negative 5, or negative 5 is greater than negative 6. So therefore, I want to bring the variable to the right-hand side by transposing the negative 6x, and that would be adding 6x. Remember, you want to line up your equals and put the 6x, in this case, right underneath the negative 5x. They have to be the like terms, right? Here's my addition bar. The 6x's go away. Bring down the negative 15. Line up the equals. Minus 5x plus 6x combines to give 1x, or just simply x. And then we recopy the plus 4. And now we have the x on the right. We'll get the numbers on the left by transposing this positive 4, or undoing, adding the opposite, in this case, subtracting 4. So you subtract 4 from both sides, line up the equals, there's the addition bar, and combine minus 15 and negative 4 gives minus 19, and that's what equals x. Okay, so then a general procedure putting all these concepts together: remove parentheses first by the distributive property, and then combine like terms on either side. Okay, here I said it last time, I didn't stress that, but on either side of the equation. And then I'm just going to say finish. Excuse me. So, an example. Okay, I'm just going to jump. I'll show the distributive property from the start here. Now I'm going to recopy. I'm in the mood to recopy. And one of the reasons why I want to recopy this one is because, okay, we're going to remove the parentheses on the left. And there's two sets. We've got the 6 being distributed, so times m. And again, remember that's understood to be a 1 in there. So 6 times 1 is 6. That would give us 6m. And then we distribute that 6 to this positive 6. And we get 6 times 6 or 36. And we have to write a plus in between to separate the terms. Now, there's just a negative out in front of this set of parentheses. So it is in this case very helpful to slide a 1 in there, because it's understood, if it's not written, that it's a 1. And think of it as distributing this negative 1 times 3m would give negative 3m, and negative 1 times a positive 5 gives negative 5, and that equals 2m. Alright, now before we start to transpose, notice that on the left-hand side we have some like terms. In particular, the 6m and the negative 3m can be combined. So 6 minus 3 is 3, carry along the m. And then we also have these constant terms of positive 36 and negative 5, which can be combined to give us a positive 31. And that equals 2m. Alright, so now the variable again is on both sides, and the coefficient is greater on the left. So therefore, I'm going to transpose the 2m by subtracting 2m, line up the equals, subtract the 2m right underneath the 3m, and that gives us m plus 31 equals, and this might feel a little bit awkward, but this is why you have to be well disciplined in terms of writing down the equal sign and knowing that it's the barrier that's very important. Because now I do need to write down a 0, because there's nothing at all on the right hand side. And then to solve for m, I'm going to have to transpose the positive 31. So we do so by adding the opposite or subtracting 31. And so then we get 31's go away, bring down the m, tuck it right in next to the equals, 0 and negative 31 combine to give negative 31. Okay, so then a final example for this homework. I'll recopy. And hopefully you agree it's useful to show the distribution with the little arrows. So 4 gets dumped in, multiplied by 2p gives 8p. And then the 4 times the negative 3 gives negative 12. The closure of the parentheses stops the distribution of the 4, so therefore we just recopy the plus 15, recopy the equals, and now distribute this 5. 5 times p, that'd be 1p. 5 times 1 is 5, carry along the p, so 5p. And then distributed, 5 times 1 is plus 5. But now once again, the closure of the parentheses stops the distribution of the 5, and so we just recopy plus 2p. Okay, now remember what I said earlier. Before you start the transposition, the worst thing you should see is ax plus b equaling cx plus d. There's more than 2 things on either side, then that means you can combine like terms. And remember, the equal sign is a barrier that can only be crossed with transposition. And with regards to like terms on the left, there's the negative 12 and the positive 15. So we just recopy the 8p and combine negative 12 and positive 15 to get positive 3. And that's equal to, on the right hand side, the like terms are the 5p and the 2p, which combine to give 7p, and we recopy the plus 5. So now the variables on both sides again. Coefficient is greater on the left, so we'll transpose the 7p by subtracting 7p from both sides. Line up the like terms, the equals, there's their addition bar. 8p minus 7p is 1p, or just simply p. Bring down the plus 3 equals, the p's are gone, and bring down the 5. And then to solve for p, we have to undo the positive 3 by subtracting 3. So subtract 3 from both sides. 3's are gone. Bring down the p, tuck it in next to the equals, and 5 minus 3 is 2. Now, any of these problems could be checked by substituting the given value of the variable into the equation. But obviously, when the equations are this cumbersome, that would be a tedious process, but feel free to do so. But also trust in your algebra skills. So if you want to check it, you can, but I'm not going to force you. Alright, so that's the end of homework number 4, and we'll see you when you're ready for homework 5.